Hello, hope you liked our previous exercise related to SMA50 and 200. Today we are going to talk, as agreed during the previous video, another scope of SMAs, which will be 5, 8 and 13. So why these simple moving averages are important? Because they are providing understanding for the user and for the market what is going on a short term and how the short term curve of the stock price is evolving. And that's also when it comes the possibility to analyze if there is any buy or sell signal. So today we are going to build a script which will show us on the graph and help us understand whether there were buy or sell signals based on these three indicators and if they worked correctly. So let's start and create our Python file with task 11. No, sorry. Encoding is changed. Task 11, SMA5, SMA8, SMA13. Okay, let's start by importing SMA5. Selecting a ticker, let's select today something else than Apple, like Amazon. Stock, we're creating data object now. Stock is Yahoo Finance, ticker, and the historical part of the data, the one we are interested in, is stock history period equals to 3 months. Now let's calculate those short, simple moving averages for a short period. Historical SMA5 is equal to historical window equals 5 days and mean value. We got the one for 5-day SMA. Let's paste it here for 2 others. It will be 8, 13, and window will be 8 and 13 respectively. Moving forward, now it's when we gather all the data about our indicator and we can calculate it, let's define whether there is a buy or sell signal. So basically, what is buy or sell signal coming from those 3 indicators? Buy signal, we consider it buy signal when the 5-day simple moving average and 8-day simple moving average both are above SMA13. So let's write our function to calculate it, detect crossovers, get this data frame. Our buy signals will be empty list. Same will be sell signals. So we have both buy and sell signals as declared as empty list, where we are going to put the data which matches to our definition. So let's provide those definitions. If DF, SMA5, I look, I, to open the loop, running too quickly. For A in range 1 length of our data frame, do the following. Is more than df SMA13 and log I, and df SMA8, as we understood, should be also above the SMA13 range. Log I is above df SMA13 and one more thing, when it comes to crossover, we understand that crossover is when something was under, so SMA5 was under the SMA13, now it's as crossover point, it turned above. So let's build it. So it was before lower, should be upper. We have covered upper part, let's cover the lower part. And TF SMA5. Let's pay attention, here goes the trick. I minus 1 is less or equal to df SMA13 look I minus 1. Okay. Let's note this. Let's go over this one more time. So initially we had three options. SMA5 should be above SMA5, 8 and 13. SMA5 should be above 13 and SMA8 simultaneously should be above 13. To check this, we are running through the ilog, which is the method to run over the indexes, like specific rows by their index position. So for each of rows of our data frame, we're running the appropriate row element of SMA5 to check if it is more than SMA13. So trying to measure apples with apples. Doing the same for SMA8 and 13, and also paying specific attention for the rule to be considered that for previous day they were below SMA13. So for this case, when this happens, we need to do the following. By signal append, we are going to add the specific data frame indexes to our by signal. So this is an option for considering it as a by signal. df index I and df close. So we are adding to our by signals list, the index when it happened, and the value of it. We covered for the by part. Now let's cover for the cell part. Elif df SMA. Now the cell signal will be when SMA8 is crossing under the SMA13 and SMA5 at the same time is below SMA8. Let's write it down as a code. I is longer than the SMA13 dialog I and df SMA5 dialog I is below df SMA8 dialog, and the last option df SMA8 for dialog I minus 1. So previously it was above, was more or equal than yeah, 13 dialog I minus 1. So this will be considered as a cell signal. In this case, cell signals and df x I f goes at dialog. So what we did here, we basically defined what is the pi signal, what is the cell signal, and what we are going to add to it when the consideration for the option execution for it will be complete. So in which case we will consider buying signal or selling signal is real. So, and with this we are going to return buy signals, sell signals. We got our method for detecting the crossover. The rest is just like work on a graphics. Buy signals, sell signals are our function for the historical data we got. Plot figure. Now we're going to display all of the data required. Size equals 14.7. PLT out. Now we're going to provide what will be the lines in our group plots. First one will be the historical closure date. let's add a label to it. Label equals, let's put it directly. Granularity of the plot. Next layer, just to copy and paste this whole line. So next will be SMA5 and labeled accordingly. This will be SMA8 and this will be SMA13. Let's change it here as well. We have plots ready, and now let's highlight the buy signals and sell signals to display it on our plot. Signal buy signals, and we will do the same for sell signals, of course. PLT alt signal 0, the first signal. We consider that for 3 months we will have not more than 1 or 2 buy signals, and mark it as the following. Marker size will be equal to 10, let's say. Color, as it is buy signal, let's have something positive in here, like green. Label it as buy signal. We will copy this and do the same more or less for sell signals. Paste here. Signals. Okay. Let's have it red and label it a bit different. We got this too. Now let's add all of it into the main plot. PLT title, Amazon closure prices and SMA solvers. PLT X label, that would be our date. PLT I label will be price, and PLT legends, and at the end PLT show. Our code is ready. Just a quick walk through it one more time. We detected the 3-month and fetched 3-month closure price for the Amazon. Based on it, we calculated 5-day, 8-day, and 13-day simple moving averages using the roller mean function from close price. We added to buy or sell signals by when 5 and 8 are above 13 and 5 before was lower than 13, and for sell if 8 is lower than 13, 5 is lower than 8, and 8 previously was above the 13. We wrote this method which will return buy or sell signals, and we are calling this method to fulfill buy or sell signals, displaying it on plot, displaying closure price, simple moving averages, graphs in the plot and marking appropriate buy signals for each of the signal from buy signal list, and displaying it all into the code, into the graph. So let's run this Python task 11. Let's see what it will bring us. Wrong somewhere. Where did we went from? More, you can see that I'm making mistakes, and voila, we have our graph. So red dots are sell signals, which we can see whenever those are placed, and 8, SMA8 goes down the SMA13. So here it goes down, 5 is below 8, so it is sell signal, and we definitely can see that there is a signal for selling the stock. Here it wasn't counted before because 8 was already below the 13 and never went above it, so the option wasn't kept. Here we again can see the crossover. 8 goes below 13, 5 was below 8, so this is one more sell signal, and that was basically true. And here it is buy signal. Here is not considered the buy signal because 5 was below the 13 and remaining below or equal, didn't cross it. And we have here buy signal because here is when all the options kept. 5 was below the 13. This is the turning point when it makes the cross. So that's the 8, and thus it became the buy signal, which is also proved to be true. And here are the stock price closure graph. SMA5 the longest, SMA8 middle, and SMA13 the shortest because it's for 13 days, and from the beginning of our graph should be passing 13 days to have it counted. This is all. Hope you liked it, and stay tuned for our next exercises or adventures. Thank you very much, and see you next time.